So question here 5 says, an electron falls from a rest. Okay, so that's the initial information. Rest means, let me just put here a rest here. So rest here, u means 0. What's u? Initial velocity. If something is starting from rest, it simply means the initial velocity of the particle is 0. Rest through a vertical distance h. So height, distance s is equals to h. Okay, in a uniform and vertically upward directed electric field. So it is upward in direction, obviously, because something is falling down, then we have to apply some electrostatic force from downward, right? So upward it is in electric field is E. Okay, great. The direction of electric field is now reversed, keeping its magnitude the same. Okay, now E, this was for the electron. Now proton falls from the rest again through the same height. So distance is again h. Okay, in the same field. Okay, yeah, electric field, they have not changed the magnitude, only the direction is changed because the proton is falling, right? So electric field is still E. Okay, great. The time of fall of the electron in comparison to the time of fall of proton will be how much? You have to check that. It will be greater, smaller, equal, what it will be. Okay, so let's see. It is obvious that it won't be equal. Option D we can directly say. Why? Because the mass is different. Na? If you imagine, like if a heavy object is falling down or if a small lighter object is falling, okay, both will have a different time, right? Different time. If all other parameters are same, be very careful. Huh? If other parameters are not same, then obviously you can talk about equal to, and you can make a situation like that. Okay, so let me come back to this. So if let's take the situation, if an electron is falling or if any particle is falling, any random particle is falling, we will consider electron or proton at the end. So let's say if a particle is falling from a certain height h in the presence of electric field E, then how to calculate the time period? So first of all, that particle which is freely falling means initial velocity is 0, and then it is experiencing some force. Something is falling down, it is experiencing a force, and what will be the force? F equals to QE, charge times electric field. And what is the force? Force will be mass times acceleration from class 11th, right? Laws of motion. So mass times acceleration here. And acceleration will be equals to what? QE by m. So if something is falling down, anything, not only electron, proton, if a person is also falling, and charged person, be very careful in presence of electric field, then acceleration will be this. It's not like if it is not charged, then the situations will be different. Okay, so A is equals to QE by m, and if A is QE by m, let's put it in an equation. Let's see what is the distance it travels in that particular with that acceleration. So S will be equals to ut plus half at square. Again, 11th and 9th standard, you are familiar with this. These are equations of motion. S equal to ut plus half at square. Sir, why only this? Why not other? Okay, in other v square minus u square, you don't have time. Okay, let me write it here, that why we have not used this equation, because here we don't have time, so we will not talk about time. We need time for this particular problem. Answer, why not first one? Because here we don't have distance, but in this particular question we are given with the distance h. So h will be equals to u is 0, half a t square. Let's take this a on the left hand side, so 2h upon a will be equals to t square. And from equation 1, let's substitute here a. So it will be 2h m upon QE. Okay, that will be equal to t square, right? And this implies that t will be equal to root under 2h m by QE. Okay, great. Now here, let's look at this formula and consider now electron and proton. Now if a proton is falling and an electron is falling, what is happening in that situation? We know that both of them have same charge, magnitude wise. Obviously polarity is different, but magnitude wise they both are equal, 1.6 into 10 raised to minus 90, right? And if you talk about mass, whose mass is greater? Proton, right? Proton is 10,000 times heavier than electron. So if it is heavier, then time will be more for the proton. So question is asking the time of fall of the electron in comparison to the time of fall for the proton. Looking at this expression without putting the values, we can say since the mass of the electron is smaller, the time will be smaller. So correct answer should be C. Why? Because it can't be greater Let it be 5 times, 10 times, 1000 times, it can't be, and it is neither equal. Why? Because of the mass present in the final expression.